So let's look at our debugging journey and let's understand the dependency problem that we face. Our first attempt to build the application failed completely because the logs showed a could not resolve error for a key TensorFlow library that we initially wanted to use. The library had been deprecated and removed from the central repository. The code didn't even have a chance to run. This is where instead of just trying to solve the code problem, you have to go beyond the trying to solve the code problem into detective mode where you go and manually check the TensorFlow repository or Maven Central repository, wherever you're downloading it from, and see where the problem is. Now, we discovered through the version history in Maven Central repository that it was no longer maintained and we needed to find an alternative. This led to a key architectural decision. Instead of a low level TensorFlow library, we pivoted to Google's high level ML kit. We specifically choose the unbundled version. This keeps our initial app download size very small. The trade off is that the AI model is downloadable by Google Play services on the first use, but it's a great strategy for keeping an app lightweight. The core functionality of the app, reading text from images, would have been the same with either of these library, but the complexity and the user experience would have been very different. So think of it like building a car. The original plan that we had of using a low level TensorFlow light library, this approach is like being given a powerful car engine. It's the core component, but it's just the engine. The developer's job then becomes with this library, we would have been responsible for building the rest of the car ourselves. For example, pre-processing. You have to manually write the code to take an image from the user's phone, resize it, and convert it into exact numerical format the AI model expects. Inference, that would be another thing you have to solve. Writing the low level code to feed this data into the model. Then post processing, the model would give us back a complex raw output like list of numbers representing characters and their position. We would then have to write more code to interpret these numbers and assemble them back into readable words and sentences. The downside, this very complex, time consuming, and error prone process. A single mistake in the pre processing or post processing code will make the entire feature fail. The second solution, which is the final solution, this is like being given a completely ready to drive car. It's not just the engine, it's the engine and chassis and steering wheel and the dashboard, everything pre built and working together. Our job became incredibly simple. The MLKit library handles all the complex steps internally. We just have to give an image to MLKit, receive a clean, simple string of text back. And the upside is it's much faster than the previous mode, faster to implement, more reliable, and less prone to bugs. So now we were able to focus on our app's feature inside of the low level complexities of the AI model. In summary, both libraries achieve the same goal, but MLKit is a high level done for you solution that saved us a huge amount of developmental time and the complexity.